sorry, let me record it. So we're trying to do this example, right? Continue with section 7.8. And here, when x is equal to t, what do we have? Thank you. Therefore, we can rewrite it as x to the 1 minus t here, right? Oh, no, wait. It is t to the negative p plus 1 divided by, let us write it as 1 minus p, okay? That is the upper limit. And the lower limit will be negative. What is it? Thank you. Very good, Corner. Look, everyone. Is it clear to all of you? We treat it as normal numbers, right? So now, it's very tricky here. So before doing that, let us write this guy, rewrite this. The first guy, it is t to the 1 minus p here. We can write it this way, right? The denominator is 1 minus p. And what is it here, the second term? Yes. 1 to the anything will be 1. So therefore it is 1 over 1 minus p. Okay? Very good. Now, the things inside here is very tricky. The power law tells us that if this power, okay, look at this. If 1 minus p is larger or 0, right? This power is positive. Then what is t? Yes. So let us write the whole limit here, right? Oops, sorry. There's a technical issue. Then this one. So the second terms here is a number, right? It's simply a number.
So is that just irrelevant since t would be going to infinity? So I couldn't even ignore that second term since it's just a number.
This is a number, so we can ignore the second terms, but it's very tricky right here. So at this point, when t, no, should be strictly larger than, be careful. When we do this, if p is equal to 1, then the denominator here is not defined, right? So be careful. Let us consider this case first. Okay? So here, if I see your question, Georgia, here, the term 1 over 1 minus p, it is simply a given number, right? So this function here is a continuous function. subtract a number, it's still continuous. And the limit, when t approaches 0, the first term matters. The second terms will be simply that numbers. So when we take the limit, it is the same as the limit. Go back to Calc 1 notes and review this. So the first term, because the power is positive, right? We suppose this is positive. Then when t becomes very large, the numerator here will also becomes very large, right? And the denominator is simply a constant, a number, given number. So at the end, the limit of these things will go to, what is it? Infinity as t is approaches infinity, right? So that is the first case. How about if 1 minus p here is smaller than 0? What do we have when it is smaller than 0? Then we can write this guy as
The first term is 0.
yes, very good. We can write it as 1 over 1 minus p t to the p minus 1, right? We can, the power law tells us that we can bring this numerator down and we change the power, the sign of the power here, which becomes p minus 1. Okay? So again, this guy, the power now, because 1 minus p is smaller than 0, or p minus 1 is larger than 0, right? The same things. Then 1 divided by a number times something getting big here, right? The denominator becomes very large when t approaches infinity. Yes, which means it approaches 0 here, right? And the limit of this guy, what is it? Limit of a constant is itself. Okay. Or it is 1 over p minus 1, right? So these are the two cases. How about when p is equal to 1? Okay, here. When p is equal to 1, we study already. One over x dx, right? And remember, it is divergent, right? So we study all these three cases when p, 1 minus p larger than 0, 1 minus p smaller than 0. In this case, it is divergent, right? And in this case, it is convergent, the second case, because the limit here converge to a number. And when p is equal to 1, it is again divergent. That is why we have the conclusion on top here, right? When p is larger than 1, it is convergent, and is smaller or equal to 1, then it is divergent. So is it clear? Okay, here. 1 minus p is positive. It means that we add both sides, add p to both sides, right? 1's larger than p. The same things, right? Or here, 1 minus p smaller than 0, it means that p is larger than 1, right? And here, this is p equal to 1. It's a different way to write this inequality. So anyway, we have proven this properties, right? From now on, you can use this properties when you see this function, okay? Integration. Are we good? Okay, let us continue. So here is the type 2 integral. Let us consider this one. We see that this is the graph of the function from x is equal to 2 to x is equal to 5. The graph here shows the graph of this function. Okay, we want to find this integral. So the bounds is finite, but the function is discontinuous at this point. It is when x, so here, suppose this is the real lines. 2, right? From the right side of 2, which is x is larger than 2, the denominator here, when x approaches 2, but from the right side, is suppose it is very near here, right? Then the terms under the denominator getting smaller and smaller, but still positive, right? Therefore, the integrand here will go to infinity when x approaches 2. Do you see it? Or you can look at the graph here. When x approaches 2, the graph of this function goes to positive infinity. Okay? This is the type 2 improper integral type 2. How about at x is equal to 2? What happened? Very good, Alu. Thank you. At x is equal to 2, x minus 2 gives us 0. And this fraction is not defined when a number divided by 0, right? It is undefined. Very good. So be careful with the domains of this. Okay. Now let us just compute this integral. So here, what should we do? Say it again, Aluk.
I was just saying if you convert it to a limit as t approaches to.
Yes, very good. Right, suppose there's a t right here, right? Then this limit will be limit when t approaches to this lower bound, but from the right side. Okay, of integral from t to 5, 1 over square root of x minus 2 here, dx, right? Very good. What should we do now? It becomes a typical integral, right? We do the limit later. Let us compute this integral. And so here, t is larger than 2, so this is easy to compute. Then, so here, the radical sign is very tricky. It's annoying, right? What should we do with that?
We make it x minus 2 to the negative 1.
Very good. You can do that. Thank you, Aluk. Walid here. It is x minus 2. In the denominator, it is negative 1/2, right? Okay. The radical sign, it is, we can write it as 1 to the power of 1/2, but it is in the denominator, so should be a negative sign here. Or let us write it slowly. If you don't remember power rules, here, right? The radical sign, we can write it as this guy to the 1/2. Then the whole denominator here, we can bring up. And when you bring it up to the numerator, it becomes 1 times this guy, but the power should be the negative power of this, which is x minus 2 to the negative 1/2. So what should we do now? It is something to the negative. Very good. I all see it. If we do substitution, and how can we define u? Very good. Therefore, the relation between du and dx will be yes. Du is equal to dx. Then therefore integral from t, we should change the limit, right? At x is equal to t, what is u? Yes. At x is equal to 5. Yes, 5 minus 2, which is 3. Okay. Then now we can do substitution. We substitute this guy. Now we write everything in terms of du. and the lower limit becomes t minus 2, and the upper limit is, very good. Okay, here it will be,
How would we write the limit statement?
sorry,
How would we write the limit statement?
the t, we just, it is a number. We treat it as a number. Let us write it. Now dx is equal to du, right? So let us take a look at this integral only. So t is a number, t minus 2 is a number, 3 is a number. What is the antiderivative of u to the 1 negative 1/2? So let us just do like a machine, right? So we do integration, then this power we just add 1 here and divide it by the same things here, right? And the limit is from t minus 2 and to 3. Okay, just do it. And finally, it will be this is negative 1/2 plus 1, and what is it? Yeah, it is 1/2, or let us write it as square root of u, right? And here, this guy will be divided by 1/2 or multiplied by 2, right? Thank you, very good. Look. Do you all see it? Okay. Now, let us substitute the value of the upper limit and lower limit here, which will be, what is it? Yes, 2 square root of 3 minus very good. Okay. Now remember, under the radical sign, the things should be positive. Does it make sense in this case? It makes sense, right? Because t here, yeah, approaches 2, but it's larger than 2. So when we write it this way, it still makes sense, okay? We are fine with that, yeah. So, therefore, this is the psi computation, right? Now let us go back to where we stopped before. We know that this guy, okay, is the limit. When t approaches to the right side of 2, right? Okay. Let us continue here. Then what do we have? Yes, it is 2 square root of 3 minus 0, right? Or it is simply 2 square root of 3. That's it. Okay?
Why is the 2 square root of t minus 2 equals 0?
It's a very good question.
As t approaches to the t minus t, or the t minus 2 under the radical, so then it ends up being 2 times 0.
Right.
Right, can you raise?
So when we have the 2 times the square root of t minus 2, and we're having t approach 2, the 2 minus 2 inside the radical is going to go to 0.
Thank you, Luke. Is it clear to everyone? Okay. That's it. That is how we do it. Very good job. Do you have any question? Good. Okay. So in this chapter, we'll study one more thing, the comparison test for improper integrals. Okay. Now, we know how to do these things, right? Now the comparison test tells us that if, suppose f and g are continuous functions, such that f is larger than g, and g is a positive function for x larger than a. Then they say that if this integral convergent, then this integral convergent. Or go back to Calc 1, when these two function, we have the properties that integral g of x dx smaller than integral of fx dx from a to c, for example, from a to t. Right? Because g is smaller than f, then the area under the curve of the g function is smaller than the area under the curve of the f function. Makes sense. From a specific interval, from a to t, for example. Then if we do the limit, both sides, right? Still true. Okay? So therefore, the right-hand side here becomes the integral from a to infinity of fx dx, right? Does it make sense? Okay. So look at this relation, inequality. They say that if this integral is convergent, it means that this one will converge to a number, or we mathematically, we write it this way, smaller than infinity. Okay, it means it converges to a number. The bigger guy converges to a number. Does it mean that the smaller guy is also smaller than that number? Right? For example, you go to a family, you see that family has 3 sons, right? The biggest one, the middle one, and the youngest one. The oldest one is smaller than 30 years old, for example. And we say that the other 2 guys should be definitely smaller than 30 years old, right? The same story here. The bigger guy is convergent, then the smaller guys is convergent. Or if B here, the smaller guy, it means the left-hand side here, If it is divergent, it means that the left-hand side goes to infinity, right? Therefore, the bigger guy, the right-hand side should also go to infinity. Or it should, if the left-hand side is divergent, then the right-hand side should also be divergent, right? But here, if we're given that g integral of g of x dx here, if it is convergent, can we say anything about the right-hand side here? No, we cannot say anything, right? It's bigger. It could go to infinity or it converge. So be careful. It makes sense, right? Okay. Or similarly, if the right-hand side here converges to divergent, it's divergent, it diverges, then we cannot say about anything about the smaller guys, right? Okay. So not complicated. So let us show this. Okay. Let us follow this guy, a solution. You can take a look at the notes or yeah, here. So they explain that we cannot evaluate this integral directly by using antiderivative of this guy. Remember in the previous chapter, chapter 7.5, the elementary function, right? Is it an elementary function, this function? First, x squared, is it an elementary function? Yes. Polynomials are elementary. Therefore, with multiplication, division, addition, or subtraction, it's still an elementary function. Therefore, negative x squared is still an elementary function, right? And the power law also remains an elementary function. Therefore, this guy is elementary. So we can take integral of this. We can definitely do. But we have to divide it into two parts. Here, we can separate this guy. Integral is simply a sum, right? When x goes from 0 to infinity here, so we separate it into two parts, this part and this part. Okay? This guy is an elementary function, therefore is integrable. Right? And this, we don't know what the antiderivative is, but you will know it when you take Calc 3 later. Okay? But for now, just accept this. But anyway, this integral, is it a constant or is it a function? Really? It's a definite function, right? It gives us the area under the curve. Therefore, it is a number, right? This is a number. So the right hand side term here, if it is convergent, then we can conclude that the whole thing here is convergent, right? If it is divergent, then the whole thing here would be divergent, right? So we break our problem into smaller problems, okay? Then, now let us take a look at the function. The integrand here. So the integrand e to the negative x squared from 1 to infinity here. Okay. We observe that when x larger than 1, then what is x squared compared to x? Which one is bigger? Yeah, x squared is bigger than x, right? Yeah, yeah. Okay, very good. Then if we multiply a negative numbers, for example, -1, what does it become? Smaller or larger in short? Yeah, smaller here, right? Okay. And the power law, e to the this guy, which one is bigger? Yes, e to the x is still bigger, right? So, very good. And previously from comparison test, right? Comparison properties. If we take integral, so this exponent, integrand here is continuous, right? Therefore, integral from 1 to infinity, e to the negative x squared oh, negative x. Thank you. Yes. Okay. Now, let us study this guy. Seems to be easier, right? Okay. Integral from 1 to infinity of e to the negative x dx. Is it an improper integral type 1 or type 2? Type 1, right? We write this as a limit. When t approaches infinity of integral from 1 to t, e to the negative x dx, right? What is antiderivative of this function? Be careful. Yeah. Be careful with the negative sign. It's very dangerous here. When x is equal to 1, 2, x is equal to t. Be careful. We are computing the integral from 1 to t here, right? And t is larger than 1, which means it will be, what is it? Right, minus of e to the -1, right? Or it is limit when t approaches infinity of, we can write it as 1 over e to the t, right? And here, negative of negative will be positive, 1 over e. Very good. Okay. So when t goes to infinity, how big is e to the t? Very large. therefore 1 divided by a very large number is still, it becomes 0. Therefore, the limit here will become simply 1 over e, right? So this integral is convergent. Right? Do you agree? The bigger one is convergent, then the smaller one here should also be convergent, right? From comparison test. So it means that this guy will smaller than, will converge to a number, and we don't compute it here, but we know that it is a number. This guy, the first term, is also a number. Therefore, the integral from 0 to infinity of this guy will be convergent, right? Does that make sense? Okay, you can take a look at the notes that I gave you. They explain it very clearly. And here is the graph of these two functions. E to the negative x is this guy, the blue one. It is larger than e to the negative x squared from 1 to infinity here. Makes sense. Okay, so I'll see you tomorrow. Have a good one.